So welcome back to our weekly program. So I started the lessons. So we're still going to continue with our frame topic, how to learn machine learning and data science faster and a productive way under our important clarification series. With the team, always let the data speak. Don't force your opinion on your data set while making AI, machine learning accessible, ethical, and life-changing positively for the masses. In what we call the AI democratization, that is making it accessible to everybody. So irrespective of your financial capability, that was why we set up this kind of weekly programs. So that and to the glory of God Almighty, we've been there for since 2020, if I'm not mistaken, 2021. So we move on. Today, we continue with this. How can you learn machine learning and data science faster and with more productivity? Irrespective of your background, even if you're at zero level, for the sake of those who joined us recently, you are very fine. Just be ready to make some sacrifice to watch some of the carefully curated videos that we prepared for such purpose. Watch them within 2 hours. You will also start modeling. So we always start with this. For those who are yet to watch those videos, why you can no longer ignore AI and machine learning. So look into its 3 series video, part 1, part 2, part 3. We look into the impact and importance of AI and machine learning. So you can't afford to miss it. If you are yet to watch those videos, let us check them out. That will really clear some doubts in our mind and put us in the right perspective. I will have to view AI. It's not something that is replacing you. In fact, because people are scared of AI and machine learning, and the thinking is that, oh, it's going to replace our job. It will replace us. AI will only, those people who learn to use AI quickly were those that will replace those that refuse to adapt to it. That is reality. Yeah, we always need you. We always need the human professionals. However, the one who knows how to use AI to support and make its work better will be more in demand. Let me give an example. You claim before we move in. See, you have a medical center. There's a medical doctor now. You have your hospital. See, and then you quickly learn about artificial intelligence, and you were able to build very powerful machine learning algorithm. You train model on several data sets in your medical lab. In your clinic, you have a medical lab section, medical laboratory section. So where you train, there are several cases, there's some special type of test. For example, when a patient is having a rare strain of maybe bacterial infection, they want to see which type of drug is going to be good for that particular infection. Which type of bacteria is he having, so that we know the drug to be targeted for it. We used to hear then they say culture. We need to culture the blood for like 3 days sometimes. Imagine a patient is already in a critical situation, and now you still need to culture his or her sample for another 3 days before you know which drug to prescribe. We all know the danger that is inherent there. Although sometimes doctor will just want to use random try and error. Let's put him on this while we wait for the culture to come out. Now we have another medical lab, a clinic that has a medical section that is AI driven. How? You know, in the past, you've had several culture in the past. Years, they are waste product. They are lying there on your file, in the laboratory recordings. Bring out those data, and then you can then train model, a very powerful model, train on several, maybe 15, 20 years of experience of culturing different samples. Use those samples, you know the final outcome, use them to train a model. You have the input, then you have the output. They identify culprit in the bacteria after the culture. Now train a model. This is the model you train after using several years of culture the outcomes. And now you have a model that is ready to predict. So when new sample comes for culture, you just put it in, input the easy characteristics of this sample, and then instead of waiting for 3 days, it will predict for you exactly what that culture is going to give you if you wait for 3 days. Of course, you can still go ahead and do the culture, but then you can rely on this prediction, especially if the prediction has been tested over time and it's having like 99 or close to 100% sometimes. And you can let it predict the cultural outcome of this new sample, and you can start treating your patient. You just need to just culture it just to verify, and you'll be shocked that the exact cultural outcome is what machine learning already predicted for you 3 days ago. So instead of waiting for 3 days, you already predicted it, and people will meet it exactly the way you predicted it. Now, let me ask that question. Who do you think people will go for? People realize that there's a clinic that has a medical laboratory that is using AI to quickly identify the outcome of a culture or any other test. For sure, it's a rhetorical question. People will go for the one that can save their life, that can save a lot of headache. If at the mere fact that the family of the sick is hearing that, hey, you have to wait for 3 days before we get the cultural outcome and the lies, it's scary. But here you have another clinic that already is AI driven. For sure, you see a lot of people will start moving to that clinic for their treatment, for the treatment of their loved ones. They don't want to take chance. That's just to give us an idea of what, when we say why you can no longer ignore AI. So the one that adopts AI, either medical laboratory test center or clinic, will be the one that people will always want to go to. So indirectly, that center, that clinic is replacing those that refuse to adapt and see how they can utilize AI. The same thing goes for other professions, civil engineers. You are building your houses. We have another one that is already integrating that insert sensors in buildings, it develops. And when there's going to be any problem, little crack, a sensor is already, the data is reported. And machine learning is able to predict that, oh, hey, you need to check so building number, so is so street. We are receiving some very strange data. It seems you may need to do some maintenance in that building. When people get to know that there is a civil engineer that does that, people will definitely rely more on them to build their houses for them than the one that is still using try and error, or that will wait for the house to collapse before they start evacuating. And this is what I call proactive engineering. One of my delivered lecture of recent to Society of Petroleum Engineers in the Middle Eastern Saudi Arabia, in the eastern part of Saudi Arabia recently. I propose what I call the proactive engineer. Proactive. You don't wait for, usually the practice is something goes wrong, we fix it. Something breaks down, we correct that. We always reactive, but we are taking it forward. We are saying we need to be proactive. We don't wait for something to break down. The pumping machine in the process industry is going to break down the next 2 weeks. We already know from today. The pumping machine doesn't just break down at random. It has some signs, the noise, the temperature, everything will have been showing signs, but we cannot detect it as human beings. But out now with simple sensors, everything is being recorded, and you can pinpoint, oh, that pumping machine is already showing signs of breaking up. Please, you need to fix it over the weekend. So this is called proactive engineering. And other aspects of our life is in the agriculture, proactive agriculture. You don't wait for something to go wrong. You already have signs that there will be pest invasion. Earlier, pest doesn't just invade now randomly. There's some sign, there's some characteristics that favors them, that invert them. So we can detect that quickly based on carefully trained model, and then we can prevent the disaster in a very early stage. And also for the exposition that we made in those videos. So I strongly recommend us to check it out, why you can no longer ignore AI and machine learning. Now, so having said that, the basic building block is very simple. Data is said to be the next oil and gas. And the good news is data is everywhere, very cheap. In fact, they are wasting away in different companies, in the universities, in polytechnics, data that we can turn to a gold mine. Imagine having an information that a student may drop out. By 200 level, we're already aware. We can be able to target this student for counseling, special counseling section, and prevent him or her from actually dropping out. Because a dropout student is a potential failure on his, it's not going to be, it's a potential crisis for himself, for his family, and for the nation. So if we can prevent a dropout, that would be a wonderful thing. Turning somebody who might have been hopeless to somebody who can become hopeful. Just imagine that in the nation. That is the work of having a proactive system working. So, and the basis is just a data set. The data is there for us. You have the data, you have the algorithms. Every day we develop new ones. So you do your modeling, you check the performance of your model, and then there's no rush. You can always go back. So there's no rush. If it's not working, you go back again and make it better. And the one, especially when you look at the one I said, I call modify iterative machine learning modeling framework to support let the data speak. So you don't have to get it at once. There's always room for you to go back. So once you get the data, do the minimal preprocessing. Don't do too much preprocessing. Otherwise, too much preprocessing may make you miss the important insight in the data set. So do the minimal, and you do the modeling, check the performance. You can always go back here, check the upper parameter optimization, change the algorithm. No matter the upper parameter optimization, the algorithm may not work for your data. And that is what we call the No Free Lunch Theorem. There's a theorem called No Free Lunch Theorem. You see, that is, there's no algorithm that solves problem excellently, always. No. You may see algorithm number A, like k-nearest neighbor. It may work for your data 1 today. Data A1 today is working fine with KNN. Tomorrow you have another data A2. It may not work with KNN. It may be working with decision tree. Another day you have another one, A3. None of these two may work for you. Maybe you need support vector machine to get it on. But you don't know which one is going to. That's why we change the data algorithm. But you change the algorithm to another one, check if it's going to work for you. But where do we start? Again, know the principle that always start simple. Make it simple. You start from simple algorithm and progress to more complicated algorithms gradually. So you start with the k-nearest neighbor, one of the very, very simple algorithm, naive-based, decision tree, logistic regression. Then later you can move to support vector machine before you start thinking of deep learning. Unfortunately, these days, people just pick data. Oh, we want to use deep learning because everybody is talking of deep learning. You don't do that. You start simple. Otherwise, you may miss the important insight in your data. So always use the principle of let the data speak. See, if you have data, the only case where you go for deep learning straight is if your data set is video or is images or you are dealing with text. You can go for deep learning in this sense because deep learning has that capability to extract the feature automatically. So you don't need human intervention. If you have video data set, you need human being to first of all extract the video features for you before you can put it into machine learning standard algorithms. If you have image also, they have to extract the image features. If you have text, they have to extract the text features. However, if you have deep learning, in that case, it will automatically extract the feature of video, images, and text for you. So it saves you that problem of waiting for someone to do that. You see? And that is why you see it being used in autonomously driven car, car that drive themselves. They are using deep learning because the car takes videos, pictures, sensors data on regular basis. So there's no need for human intervention. Automatically it extracts the feature and then it goes to the processing unit where the model predict what to do. Hey, you need to stop. Somebody is crossing the way of the car. You need to press your brake. A car is very close in front of you. All those kind of decisions are taken proactively. However, if it is not real time like this, even when it is real time, the moment deep learning extract the features, you just transfer your data. You can put it into standard machine learning algorithm and also let the deep learning also do the modeling itself. Let it do prediction for you. Compare the result of the standard one and the deep learning. In some cases, our students, some of them have gotten better results when they use standard machine learning algorithm on data extracted using deep learning. Let's pay attention for this. It's going to be like an hybrid model. You use deep learning to extract the feature, but once you extract the feature, then you can use any other machine learning algorithm. So we can let it go into the deep learning algorithm itself to do the final prediction. We can also let it go to train and then predict using standard machine learning algorithm. So I have an SVM here. It's benefiting from the extracted feature from deep learning or by deep learning. And we also have a deep learning CNN that is also doing training and testing to predict for me. I can compare the result of support vector machine and the final output of this CNN. In some cases, you may be surprised that SVM perform better than deep learning. The only advantage deep learning provided is automatic extraction of the data set. This is an hybrid modeling scheme that somebody may also investigate in his or her own research work. When you use deep learning to extract feature from the images, from the videos, from the text, let the result go to both deep learning classifier and also standard machine learning classifier. Compare the results and see what you are getting. And of course, ensemble is also there. Sometimes we need to make use of ensemble learning just to improve our performance. You can go back. Sometimes you may need to go back all through to this place. The data may not be good enough. After changing algorithm, try different hybrid, nothing is working. Ensemble is not working. Maybe you got the wrong data. You may have to go back to feature engineering, manipulate the features, generate new feature from existing feature, combine one or two features into one, you see, and then try to see or do feature selection. See data down sampling or do feature selection, whereby you can try to see maybe something is wrong with this feature. Maybe there are some data set that is very dirty. How can I improve those data? Can I remove them? Try to identify those data sets that may be giving your model problem, and then try to, so that you may get better result. So you may have to go back here, do a lot of feature engineering. Part of the stuff you can do to your data set is try to say, okay, can I really use clustering to identify data that is not good? For example, I have a classification problem to classify if this patient is sick of hypertension or not. But after running a lot of modeling, I couldn't get good result. Then I may send the data to clustering algorithm. I use clustering here, you can see. I say, please, can you cluster this data into 3? It's supposed to be 2 data. Those people who are sick and those people who are not sick. We are deliberately asked it to classify it to 3. I have like 1,500 samples. At the end of the classification, I got like 700 in group A, another 750 in group B, A, B, and now I have another 50 in another group C. Then I may infer that this is likely going to be one of the sick person and the one that are not sick. This may be the one that is destroying my model. They didn't belong to either of these two. I can then identify these 50. We call them outlier or very dirty data, and then we can kick them out. We remove it. So now we are now having 1,450 samples instead of 500, 1,500. We are able to delete 50 that are causing trouble. Sometimes you may find out that this exercise will let you go back again and then run your modeling and check the result, and you may be able to get better results. That's another way. If it's not done, you may have to go back. We still have what we can do. Do attribute selection. We have 15 features. Can we reduce it to 5 or to 14 or to 2? We have other things we can check so that we'll be able to get better results. That's what we are targeting. And sometimes it may not also work. We may use things like PCA. We call it feature reduction. Feature reduction. PCA. Principal component analysis. When you use principal component analysis on like 15 features, it may generate for you 4 features. None of the 4 features will be present in the previous features. It's a kind of a way of manipulating features. They will generate a totally new 4 features that are representative of the 15 features you are having before. That is PCA. Sometimes we use it in case things really get tough, but then it doesn't guarantee that it's going to get you better result always. It may work in some cases, it may not work in some cases. And that is why we propose what we call in our new book, Let the Data Speak, I propose what I call the multi-channel pipeline. Multi-channel pipeline. So for everyone you do, you make it a pipeline. Another pipeline, another pipeline. You now load the result of each of the pipelines, and then you can compare which of the pipelines is giving you better result. Then you can go for the one that gives you the better result, the best result. And this again reinforces the reason why we always say that data science projects are better done in groups. In a team, you have a team of 3, 5. Optimal team is 5 in data science. Work together. Let Mr. Mam work on pipeline 1, pipeline 2, pipeline 3. You work on pipeline 3, 4, 5, 6. Another one work on another pipeline. Finally, you bring all the results and see which one is working for us better. And then you can select the one to go with. So the going back and forth will continue until you are able to get what you need. Sometimes it may be that you are working with the wrong data set. No matter what you do, you are not getting what you are supposed to get. You see, you may have to go back to data preparation. This is why you have to go back here. The aim is to improve the performance. Maybe you got the wrong data. You may have to go back and some missing values you are trying to replace are not doing well. Go back to the source of the data. Or maybe you even use the wrong data. You are using diabetes predictive data to predict hypertension. Something totally different from what you are targeting. Some of the decisions you have taken with your medical doctor is not going on well. So you have to make sure, go back again to your data preparation, make sure you have the appropriate data. Now, so a quick one I would like to mention. So, but because of our time, we'll just introduce us to this. Later, we'll look in more detail in our subsequent gatherings. Not really. Type of analytics. You see, when you have this called machine learning-based data science and analytics modeling framework with feedback mechanism and the analytic options. When you want to use data science, machine learning-based data science in your own area, in your field of endeavor, the first thing is for you to understand the business, we call it business understanding. What do you want to use it for? What do you do in that area? See, you understand what you are doing, you're a professional in your area, so that is fine. Then you have which analytic option do you need? There are different ones. Analytic option, very important. So after you did, okay, I'm going to need this, I'm going to need this, then you now start studying the data requirement. We are going to pick this next, the analytic options available. We would like to start look at the data requirement. You start collecting the data. After you know the data requirement, you start collecting the data. You have to discuss with your data science consultant. So your AI consultant has to guide you. Which kind of data are you going to need? Is it imaging data, or video data, or text, or just numerical data? See, it's always good to start simple. Start with numerical or categorical data set, demographic data, before you start going to imaging. Imaging has its own challenges. For example, you want to do medical diagnosis of a particular lung disease. You're starting with imaging. The fact remains, not every hospital will have that image capturing machine. Some of them may be very weak. They are not accessible. villages don't have it. So you go for the one that can go around first. Let's get simple demographic data. If we have demographic data for those people with any disease of the lung, once we train our model with massive data, it can predict who is having lung disease. It doesn't have to be image always. We have to start simple. In fact, research have indicated that when any disease attack, it takes time before it becomes very obvious in the lung. So even when you start taking the images, it may not detect the disease at very early stage. Take for example, if you take imaging of somebody with any lung disease, at very early stage of the disease, the lung may still be very okay. Because before the disease really shown, just like during the COVID-19 era, you see, people start using images to detect. They notice that somebody will already be suffering from COVID-19, but the imaging from the lung is still looking fine. It takes days or weeks before the lung starts showing signs. But before then, you have simple data set that can be used instead of that. So this is what we're talking about. So we have to look at the data requirement, which kind of data, take it simple, use demographic data. If of recent we start trying questionnaire-based data, that you don't even go to clinic, because a lot of people, patients, especially in people from resource-constrained area, we got to know that when they go to clinic for medical checkup and they ask them to go and do some medical lab work, most of them don't come back. So these are from field experience from our medical doctors interviews. Some of them, majority of them, they don't come back because some of them don't have the money to go for that medical test. That's why you see most of the doctor practices in resource-constrained area. They usually try to avoid telling their patient to go for medical test. They just look at them and try to ask them to, by trial and error, this is what you are suffering from. But they know that if they ask them to go for tests, they are not likely to have the financial wherewithal to do those medical tests. So we came up, okay, why don't we do questionnaire-based diagnosis? Ask them a few questions, and based on massively trained machine learning model, we can be able to predict what this patient is suffering from at a very early stage, so that doctor can then be able to continue with the proper treatment. Sometimes symptoms could be similar across different diseases. I've seen people being treated for malaria for weeks, only to realize he's having typhoid. Now, it's okay. Why don't they do typhoid tests, wider tests? They say the patient has no money. You see, we can use the little variation in typhoid symptoms and that of malaria. But with a well-trained system, we may be able to prevent this kind of disaster, where you are training people for malaria, meanwhile it's actually having typhoid. Before you realize it may be late for that patient. So these are some of the very nice intervention systems we try to build with basic interview, ask them questions what you are feeling, because we already trained a model using same questionnaire that is working. We can ask them a few questions and be able to predict that you are suffering from typhoid with very high percentage accuracy that the doctor can trust. And then we do testing for some patient after the prediction to confirm if the prediction is actually right. If you can do that several cases and you confirm it, then you can then declare it. This system is declared trusted to be used for this kind of prediction. This is what we're talking about. So you look into the data requirement, data collection, very vital. Which kind of data you want to use? I've explained that, understanding it, and then you can then prepare the data for modeling. Know that you can always go back. That's if you can always go back to refine it. We notice what we are collecting may not be what we need. Let's go back and change it. You go to modeling, you evaluate it. Is it working fine? No, you go back. Is it working fine? You go back. You keep going back and forth. If it's working now, you deploy. Then you see our feedback. The feedback needs that, we need to improve this model. The performance is going down. You see, we didn't track some of the characteristics of this local patient. maybe you move it to another village. Then you can always go back to modeling. From modeling, you can go back to data preparation. You can go back to data collection. Even data requirement may need to change to improve your modeling. All this because you want to make sure you are getting the best possible outcome. Now, we now look at the approach you want to use. Which analytic approach? We have 4 analytic approaches. See, we have what we call the descriptive analytics. We have the diagnostic analytics. We have predictive analytics, and we have prescriptive analytics. That is data analytics types. So the descriptive analytics, because sometimes you may not need all of them. This is what you need to decide here. What is the analytic approach you want to use? You cannot decide that as a client. Your consultant AI guy will guide you based on what you need to do. What do you want to do? It will advise you. In most cases, majority we pass through descriptive analytics, because this is when you monitor what happened. You cannot help. You can't do anything here. It has happened, but we need to understand what happened. Like they used to say, when you fail to understand your history, then you may be running yourself to trouble. But when you understand your history, you know where you're coming from, you know the mistake you made in the past, then you can be able to straighten your way and prevent yourself from falling to the same mistake you made earlier that cost you a lot of trouble. So that is why we do what happened, descriptive analytics. Bring the data set forward. Bring the data set forward. So like I was saying, ask the question, what happened? Descriptive analytics. So what is happening to the data set? Why do we have low sales in those places? Could we have done anything to make it not like that? For example, let me show you this. See, this is under the descriptive analytics, showing the 4 main types of analytics and the corresponding properly framed question and the machine example for each type, and how they vary and progress from one type to another. This is what happened. You want to see your monthly sales dashboard. Monthly sales dashboard. It's usually historical. What has happened in the past. You can't change it, but you can learn a lot of lessons from it. What is the sale in branch A, sale in branch B? Why is sale in branch A higher than branch B? But last month, it was the opposite. What happened in that town that made the sale to change like this? What can we do to make it continue to happen so that we continue to make the sale while raising the sale of other places? So that is trying to understand what happened. That's the question we want to resolve, and usually at the simple level. Here, you may not even need machine learning. You don't need machine learning to do that. You just need some statistical analysis, some pictorial visualization. Use more of statistic here and visualization. You visualize what is happening. How many customers are we having? What is the customer distribution? How many male and female do you have with the customer? You want to have an idea of your customer base, so that when you want to give end of year gift, souvenir to make them happy and come back next time, you give them according to their gender. Ladies they like some things, men like some things. That is, you see the way people will respond to you. You don't just give gift. You look at you do profiling of your customers. You understand the psyche. This one is an accountant, is working in banking, is a lecturer. He will like this one. So you have analytics to determine, okay, this customer should be targeted, give him this gift at the end of the year. It doesn't have to be the same thing across board. Imagine somebody is a poultry farmer. A poultry farmer, you didn't know that. Now, at the end of the year, you decide to give them 10 crates of eggs. It may not make more difference to that poultry farmer, because he will likely give it out to other people, because you are giving him what he has in abundance. You see? So this is one of the advantages of analytics. You are able to have informed decision. You'll be able to make informed decision. You understand the base of your customer, where they're coming from, what is their profession, what are they going to like if I give them end of year gift. All this may be possible for ordinary human being. But with data-driven decision making, you can do it and do it even better. So that is descriptive analytics. You use statistic and visualization, like drawing this kind of bar chart or pie chart to try to understand what's the percentage from each areas. In all, you want to understand what has happened. It's a past tense, but we need to understand our history if we can move forward. The next one to it is what we call diagnostic analytics. Diagnostic analytics. Why did it happen? Why did it happen? What went wrong? What could we have done to warrant this result? Investigating why sales drop last quarter. Want to investigate why the sales drop for the last quarter. What was responsible? That diagnostic will answer the question, what was responsible? And if we know what was responsible, then we can be able to do what? To see how we can prevent it next time. I think at this point we are going to we're going to have a stop because of our timing to give room for question and answer while we continue, by God's grace, next week with diagnostic, predictive analytics, prescriptive analytics, and how we can relate it to real-life examples that we'll be dealing with as individuals. Thank you very much for listening. So we are now going to question and answer section, as the case may be. Thank you very much.